Well, the sum of a finite geometric series is a little more complicated than the sum of a finite arithmetic series, which is what we kind of had tried to discover as a group yesterday. But a lot of the things remain the same, with one exception, is that a sub 1 is the first term, and r is the multiplier. So those are that we dealt with yesterday. This is new. You look around, that's all you're going to need, where n represents the number of terms in the series. Okay, so if we're going to set this up, and if we want to find proof, we know it's 312 because we added them up. But if we plug it into this to this equation, we'll see how it looks. So a sub 1 is the first term in the series, so we have a 2. And we're going to multiply that by 1 minus the ratio raised to whatever power. Now that's 1 minus r to that power. Well, the common ratio, or the multiplier, is 5. Okay, if we're multiplying by 5, but n terms, this is 5 to the power of 4. Now that's a number right there. We'll deal with that in a second. This is all going to be over 1 minus the same r with no power, so 1 minus 5. So this is going to be a big number. We're going to need to deal with this here in just a second. 5 to the 4th power, well, 5 times 5 is 25, times 5 is 125, times another 5, the 4th time, is equal to 625. On the calculator, 5 raised to the 4th power is, in fact, 625. However, we're going to take that away from 1 and then multiply it by 2. So this is 2 times 1 minus 625, or a negative 624. Okay, because that's the 1 minus the 625. Okay, and that's all over a negative 4. Right, so 4 actually goes into that number, but if we say 1 minus the previous answer, and then we multiply that by 2, and then we divide that by negative 4, guess what we get? Oh yeah, the same 312. So 312, that's kind of our proof. It's showing the work by plugging in the numbers that we found there. And I guess if we extend it, we can do this here. Extend the original series by 3 additional terms. So we're going to multiply it, times 5 and times 5, 250, times 5, and then times 5, 2 more times. So plus 1250, plus 6250, and then plus 31,250. Okay, so we've extended it. Use the formula in number 3 to find the sum of the new series. Now this is going to get bigger, so we can add all that together, but it's 2 times 1 minus 5 now to the 1, 2, 3, 4, 5, 6, 7th power, okay, over 1 minus 5 still. So this number on top is obviously getting bigger. 5 raised to the 7th power is that crazy thing. So we're going to say 1 minus that number times 2 divided by negative 4. That would be 39,062, comma. And I believe that is that.